Hi, my name is Tori Morgan, and I'm a postdoctoral research associate at the University of Illinois, Urbana-Champaign, working with the Quantitative Sustainable Design for Sanitation and Resource Recovery Systems package, also known as QSDsan. Today, we'll be going over our tutorial number 6 on system, and we will achieve two objectives where we'll create a system and learn how to retrieve useful information about the system. Let's get started by opening up our systems tutorial and the Read the Docs for QSDsan created by Yaolin Li. Then open up your Jupyter notebook if you haven't already, and we're going to import QSDsan. As always, we want to see what version we are working with, and it's going to be especially important for this tutorial. This is because at the time of this video, for this tutorial, you need 3.7 or higher in order to run through the whole tutorial. If not, you'll get stuck at about code block 8 when we try to make our reactors right here. So make sure you have 3.7 or higher. If you don't, you can do a simple pimp install, PIP install to upgrade your QSDsan. So now that we have imported QSDsan, let's create a simple system. System objects are used to organize one or more unit operations in a certain order and facilitate mass and energy convergence, techno-economic analysis, and life cycle assessment. At this stage, we won't include any of the process models that will be in future tutorials. We will just use surrogate units to represent it for now. Our system will consist of, and we can see by running this code right here, so our system will consist of 2 anoxic tanks right here, and then 3 aerated tanks with a clarifier. And you can notice that we will also have 2 recycling units. So we have one coming from the clarifier back into that first anoxic tank, and one coming from the last aerated tank into the anoxic tank again. So let's move on. First, we need to, as we always do, is set the components that we want to work with. And remember, if you ever forget how to set the components, you can always refer back to the component tutorial that was the second tutorial in the series. So we will load the default components for now. And we can take a look to see what those default components look like by simply typing in components or CMPS. And then we can see all of our default components. But maybe we just want to look at water for now. Well, we can set the synonym for it. And have components H2O set to components water. Okay, and then we can set our thermo components. And then let's create our Influent waste stream. And so to create that, you can call it whatever you like. We're just going to call it WW for now. And we have our flow rate set and the units that we're using for our Influent. So everything looks good. You have all the details about your wastewater waste stream. And now that we have our components set and we created our Influent waste stream, we can now make the first 2 reactors. And you'll see A1 has 3 ends. It has that wastewater influent that we created. And then we're using placeholders for now, but we have recycle 1, and that's the recycled stream coming from the last aerated tank. And then recycle 2 coming from the clarifier. But we can connect them to those corresponding units after we create them later. And then for A2, you'll notice that A2 for the ends, we have A10. And so what that means is it's taking the first the first output from A1. So you can see here, the expression with hyphen is pipe notation. So U10 is equivalent to U1.outs. So A10 is equivalent to A1.out0, with 0 being wastewater because it's the first, and in Python, we start at 0. If we wanted to include recycle 1 and recycle 2 going into A2, say nothing happens, they just go through A1 and then into A2, then we would have ends equals A10, A11, which is the second N, and then A12, which would be the third N. And if we rename these later on and say this comes from A4, and it's the first output of A4, then recycle 1 here would be A40 hyphen 0. So once we go through a little bit more, you should get more comfortable with it. But just be careful that you're using the correct numbers. I know I've messed up before and accidentally had 1 for 0 or something like that. And it takes a minute to figure out what you did wrong. So now we can move on to our oxygen streams. And so because we had 3 aeration tanks, we will have 3 of those streams. So let's copy this code right here. I believe, yes, I did run it. Okay. And so we have oxy1 equals QS.waste stream oxy1. And then we have oxy1.imol. And then oxy2, which is just going to be a copy of oxy1 along with oxy3. So now we can set up the 3 aerated tanks. You could call it AO if you wanted to, AO1. We're going to use O1, O2, O3. And just like before, we had to create that wastewater stream to be the first influent for those anoxic tanks. Here we created those oxygen streams to be for our aerated tanks. So let's see, O1, QS tank, this is our mixed tank. Our ends are A20, so that's our stream, the first stream coming from, or I'm sorry, the first out coming from A2, so A20, and then that oxygen stream, oxy1. And we do the same for O2, where the first input is going to be the first output from our first oxygen tank since they go in order. So O10, oxy2, and then the same with the third tank, it takes in that first output from the second tank. So O20 and then oxy3. Now we can work on our clarifier, which is essentially a splitter after the last aeration tank. So we can copy this here. I'll walk you through the line. So we have S1, which is our splitter. And then for the ends, it's taking the output of the last aerated oxygen tank. So that's why it's O30. And then for our outs, this is just a placeholder right here, but we can put solubles. And then it's also taking, it's sending the out to be the first influent, or I should say second influent for the anoxic tank. So remember, if it was 0, that's the wastewater stream that we created. That's the first influent. It starts at 0. Here we have 1A1. So that's the second influent for A1, which is our first recycle stream. And then we have split 0.9 right here. So that means we want 90% of the influent to go to the first out or the first effluence. So the zero effluent. So run that. And then, like I mentioned, the clarifier, which is a splitter, we will ignore the part that the splitter does not have cost. In reality, a clarifier would have cost, and you'd want to specify what those costs are. And so they're going, here we're assuming, like I said, 90% of it's soluble, and then 10% is a liquid stream, and all the solids go to sludge. So we're going to run this code right here. And this tip is showing you what this code would look like in a more simple form, where it's saying if it's our particulate, it goes to 0. If not, it goes to 1. And so here it's saying if it's soluble, it's that 0.9. If else, it goes to the other splitter, which we're going to create right here. So here's our second splitter. So now we have QS.san units.splitter, and we have S2. Our input is the first output from S1. And then our output is a liquid effluent, and the third input of that anoxic tank. So remember that recycle stream 2 is what's coming right here. So 1A1 was recycle 1, 2A1 is the recycle 2 that we see right here. Because again, 0A1 would be this wastewater stream. So now it's time to create the system. And since we can only handle one recycle, we're going to need to create two systems, an internal and an external system. So first we can import BioSteam as BST. And then let's run this internal system. Oops. Sorry, I was trying to create more lines there. Okay. So we have our internal system. The order of our path in the internal system is that anoxic tank, A1, anoxic tank 2, the first aerated tank, second aerated tank, third aerated tank, and then that first splitter. So this is the one associated with the solubles right here. Also, it's taking in the recycle, which is the recycle stream from S1. Run that. And then creating the second system. You'll see this one's a little bit shorter than the internal system. So we have our external system. The path is the internal system with the addition of that second splitter, which is our second recycle stream. So let's see how our system looks and if it's what we envisioned in our heads. Okay, so we have the wastewater coming in as our first stream, but then you see we have these other streams. So there's one coming from the first splitter right here, and then we have that second splitter coming into A1 as well, into that anoxic mixed tank. And then it goes, the output of the anoxic first tank goes into the anoxic second tank. That output goes straight into the first aerated tank. And you can see we also have our oxygen stream coming in order to aerate that tank. And then we have our second oxygen going to the second aeration tank. And then our third oxygen going into that third aeration tank. And then this will, from the output of the third aerated tank will go into that first splitter, which will be split between the first aerated tank and then that second splitter. And then our liquid effluent. So it looks like it all ran correctly, which is great. So let's see, we can now retrieve some useful information. So and we can look at what units are within our system. This is always a good check too, to make sure that everything's running correctly. So we have our mixed tank A1, mixed tank A2, mixed tank O1, mixed tank O2, mixed tank O3, and then our 2 splitters, which is correct. And then, so those are our units of the system, but as we just created with the internal system and external system, we also have our paths. And so here we have our internal system and then splitter S2. So now we can simulate our system similar to how we simulated our SAN units before. You can check those out in the SAN units basic or the SAN units advanced tutorial. And we can see how those look as we simulate them. So I'm not quite sure why I have S6 and there's S7 there, but I can check that after. But it looks like we have our streams correct, which is our wastewater, oxygen 1, oxygen 3, oxygen 2, and then our external system, the liquid effluent, and then out. We can look at our attributes that relate to cost and see what is our purchase cost of the system and what's our installed cost of the system equipment. So here's our purchase cost of the system and then our installed cost of the system equipment. We can also look at operation and maintenance. So if we set the operating hours of the system, like we do here, we can see the costs related to the operation. And then here's electricity. So similar to the purchase cost, we're doing or getting the electricity consumption and printing that out and the electricity production. So this system, it doesn't produce any electricity. If we had maybe like a biogas reactor or something that could convert the energy to producing electricity, that might show up here. But as of right now, it's just using up electricity from what I believe is the aeration tanks that we installed. We can also look at heating and cooling of our system. And right now there aren't any heating or cooling system or heating, cooling duties in our system, so we can add those to demonstrate. So we have our first heater, our second heater, and we'll put that into system 2 and clarify the path for it. And then for system 2, we have those operating hours, and then we just need to simulate and print the diagram. So let's see. So you see after the splitter, also one thing I didn't know earlier that you can see here is that the paths are noted by these like dashed boxes. So you have your internal system path right here, your external system path that includes everything from the internal system plus that S2 splitter. And then outside of that, you now have your system 2, which has the heater 1, heater 2 that we simulated. And we can also see the amount per year of cooling and heating. So the cooling duty of the system we have, and the heating duty of the system we have. So that's all we have for the tutorial on system. It's very important because it brings all of your SAN units together. And so as you get more familiar with the notation, like the pipe notation, I think it'll get easier and smoother as you go along. And as always, if you need to reference other tutorials, such as the component tutorial or SAN units, you can go back to QSDsan, read the docs page. Or if you want to look at other codes and more information, you can go to the GitHub group for QSD group. Thanks for watching a tutorial on system, and we look forward to doing more in the future on techno-economic analysis and life cycle assessment.